Alright, good day guys. How are you all doing? We're talking about bicycle compound, or we say the bicyclic compound. Simply because the movement is in terms of a ring. And there are three things that needs to be noted on that the bicycle compound, or you say bicycle compound. Is that you have the bridge, you have the fused, and you have the spiral. And mainly this bridge is just like someone who is actually given a one child at the middle them, center them. While this fused is someone whereby has no womb, so you have zero. When we get to that, we'll explain better. And you see this spiral is more like you having a X shape, then this. Let's start from the first one, and this is the bridge. This is the bridge. Now, guys, how do you name this compound? Mainly, this is in terms of the molecular compound. When I want to write it out normally, since I have one carbon here, this carbon you are seeing here, this carbon you are seeing here, is just like you're talking about a dimensional structure. This is shooting out. Are you get what I'm saying? So since it is shooting out, let me write it normal in the olden days way. You have this like this, and mainly moving like this way. You have this way, then you have this idiot coming in like this. You also have this idiot moving in like this. So let me make it what is this duster? Okay, let me put it more. I don't like drawing, so I don't like drawing at all. So we have this more like this, coming in like this way and meeting it up this way. This is much more better. And we have this, like this, like this, like this, and this way. So this is much more better. Forgive me if I can't draw very well. I don't like drawing. So if you have to look at this now, there's one thing you have to note. Look at this, guys. Let me read out some things into you here. It says the carbon atom common to what? To both rings are called the bridge head. Now, if you look at this, movement from here to this point, movement from here to this point, movement from here to here, movement from here to here. There is one thing that is common. This idiot here and this idiot here. You see these two idiots here are called the bridge head. Are you get what I'm saying? So therefore, it says that what? The carbon atom common to both rings are called the bridge head. Why is that? Moving from here to here, this is common. From here to here, these two are still common. Here itself, these two are still common. Then guys, it says that each chain of what? Of the atom connecting that bridge head, are you with me? Is called a bridge. This is called the bridge head. And since it now depends on total amount of bridge connecting it. Now guys, if you look at this, just only one bridge head here. So this is one carbon atom connecting these two. If you have to look at it now, connecting from here, you have how many, guys? You have what? A two carbon what? Bridge. That's a two carbon atom there. Same thing goes to here. This junction, 1, 2. This junction, 1, 2. This junction, ordinary 1. So therefore, looking at what we've drawn here, you could know that we have 2 here, you have 2 here, and you have 1 at the middle. Now, how do you name it? Mainly, it is like a normal way of naming alkane. We count the total number of carbon that is there first and foremost. So we counting 1, 2, 3, 4, 5, 6, 7. Or you say total number of carbon 3, 4, 5, 6, 7. So we all know that what we have the heptane. So having heptane, that is one thing. And we know this is a what? This is a bicyclo compound. So having a bicyclo, then something we call period has to be here. Something we call period has to be here. Now, before I put this into it, also, in a normal dem, this is the olden days structure. When you want to write it more like a pro, which I am not, you have to understand something. We know we have two compounds here, right? So you have your two compounds like this, your two compounds like this, joining with another compound, meeting up with having another compound joining with it, having like this, then Like I told you, sorry if I can't draw very well. So more like, then you have a connection bridge from here, having this, cutting this point here. So these two, as you can see, these two here, I told you guys that this middle point is not actually directly staying here, it is shooting out. So more like you can say shooting out like this, like a pistol. So that is the same thing as this. So this is the normal method you do see most often in our normal days now. So guys, moving on to this, then after you know it is a bicycloheptane, what do we do next now, guys? The rule is that we total the total number first, 1 3 parent chain heptane. We know it is a bicyclic compound, and what do we insert here? That's what you have to think. Now, you just have to insert the total number of rings present there. That is, if I'm to from here to here, I have 2 rings, right? These 2. From here to here, I also have I have 2 rings here, 2 rings here, and we also have 1 carbon point here, which is ordinary 1 ring. Moving from here to here, you have 1 inside. That was I said I what. That was why I said this only carries 1, just like 1 child, 1 here. So, and how do we put the periods here? It's in terms of the sentiment. That's from the word, the highest to the lowest. So here normally we know you have 2, so you can just easily put your 2 point, your 2, and your what 1. So you have the bicyclo 2.2.1 10 what guys 10, and we know our numbering. You're numbering from 1. Now actually for to number a normal dem where you don't have solid doesn't have any issues. So instead of you numbering this, you don't have any issue numbering because we don't have any substance we want to include. So you don't have issues numbering it, like I said. But if you want to number it, it's still cool. There's no issue about that. And if you want to number it, let me call your attention to that before I move to the substituents. If you want to number it, you have to number it from the bigger range first. But if you look at it now, this is smaller, so I don't have any issue. I number from here, but you have to also start from the bridge head, either of the bridge head. And when you are numbering it, you have to number, just like we do say, naming number, okay, you have to number the one closer to the substituent you are about to put down. Are you with me? So you have 1, 2, 3, 4, 5, 6, and the middle point here, this cuts what? This cuts 7. So we all know this shoots out here, this point here. So you have 7. This is the bridge edge. 1, 2, 3, 4, 5, 6, and your 7. So this is I found this fascinating, very interesting. So this is a bridge head. All right, guys. Having this is a fused bicyclic compound. And how do we name it, guys? If you have to look at this, you see that there is no any compound at the middle, so we don't have to shoot anything out. And as you all know, like I told you guys, this is a girl who can carry womb. So therefore, this is 0. So sorry, ma'am. All right, guys, moving on to this. And I guess some people might be confused that how is this H2C and this H2? Now actually you can name this like H2C, yes, just like a normal multiplication rule. Are you with me? But not just to give the heads to whom the heads belong. That is why you have the normal head before the the cycle. But you can also do it like this. H2C and CH2 is the same thing. Now guys, this could be reshaped back as your normal thing, like it's something like this. Sorry if I'm not getting it well. Let's just say you have something like this. Let's put it that way. And something like this. More like a space jet. More like a space jet. And as you can see, this is our 2 words bridged. And this connects this at this 1 point and at this 1 point. And this is what? This is 0. And it is a bicyclic compound, yes, of course. And since it doesn't have any substituent, we can easily name it. First, we count it. How many carbon do we have there? 1, 2, 3, 4. So this is a butane. A butane, and that will be bicyclo. We told you guys already, from the highest value, you have 1.1.0. Then you have what, guys? Butane. So that is how to name the fused carbon atom. Just give reference to 0 here. That's a woman with no womb. Now guys, let's name these 2 things. This is a combined structure where you have the bridge. This is the bridged and the fused. But we ordinarily have the normal bridge here. So, and also with a substituent. and this also have a substituent. So let us see, how do we go about that? How do we go about that? Now guys, it's very easy to understand. As we all know, we start from here, right? Our counting starts from here. But before that, you have to identify the longest ring. And if I could count, I have 1, 2, 3 here. So I have a 3 ring them here, 1, 2. I have a 2 ring them here, and I have 1 inside here, as you all know. Now guys, then we have to check, where do we start our counting from? If I were you, since I had known that the substituent here is at the last point here, and as you all know, this last point here will be counted last. It's always counted last, so we don't have any issue. But this we are gonna have a little bit issue, but simple. So let's count, and mainly take note, guys. Whenever you are counting, you count from the biggest, irrespective of whatever you want to do. So if you want to look at the substituent, you either count like this or you count like this. You don't count like this. It's simply because this is the smallest. Not that you don't count like this, but simply because this is the smallest. So since this is the biggest, if I'm to count from here, I don't have any issue. 1, 2, 3, 4. You know, I have my 5, I have my 6, I have my 7, and the middle point I have 8. And so therefore, methyl, this is a methyl substituent. Methyl lies on what? 8. So just like you guys don't name your compound, 8 methyl. As we all know, 8 methyl. Then what do you put there now? The compound itself. Bicyclo. Then we put our degrees. The first degree, the second degree, the third degree. You have 3.2, 3.2, 0.1. And as we all know, we have 8 there. That total longest carbon chain is 8. So we have octane. So we have 8 methyl bicyclo 3.2.1 octane. Let's come to this idiot here. Now, having this idiot, what do we do? First and foremost, you know this is 0. I'm going to count anything. This is 0, yes. Now we have to locate the longest the degrees. This is the point, this is the point. We have 1, 2, 3, 4. So I have 4 here, and from here I have 1, 2, 3. I have 3 here. Are you with me? So guys, as you all know now, we have to give reference to counting of numbers very well, simply because the substituent isn't in does not even lie, and say first step, this does not even have a middle point. Secondly, the substituent is not in the last bond here. So we have to look and you have to think twice. And where do we start from? You have to start from here. I have 1, 2, 3, 4, 5, 6, 7, 8. I'll have my substituent at 8 here. But you want to start from here. Let me put the numbers there so you can understand what I'm saying. 1, 2, 3, 4, 5, 6, 7, 8, 9. Are you with me? You have 9. And you can't count, no, you can't count anything here. Just only give degree. There is no carbon chain here, no carbon, nothing. So I've counted from here, right? Let's start from here also. 1, 2, 3, 4, 5, 6, 7, 8. So which means this is actually lucky, still on 8 and 8. So you cannot speak any. So you have 8 methyl again. You have 8 methyl, and we have total. So you have 8 and you have 9. Are you with me? So 8 methyl, the degree given to it is what? What is the degree? 4.3.0. 4.3.0. And as we all know, 8 methyl 4.3.0, we have no name. You have no name. So that is the naming of this trash. Let's talk about the spiral. Alright guys, talking about the spiral ring, it is also a little bit easier to name, but they reverse them. You know, for bridged and the, what do they call it, the fused, we name from the highest ring, but for spiral, who is your guy, we name from the lower ring. Are you with me? So from the lower ring. Yeah, a lot. So how do we go about that? And mainly depends on total amount of ring you are being given. No? But there is nothing at this middle point here. You don't have anything. You know, someone that is not alive. So let's say I was given spiral, you know, maybe 2.2.2, just have to keep adding some structures to it. Are you with me? Like that, I know. But for this two now, you only have two them. So 1 and 1. So we're only giving 2 periods to it. Same thing goes to here. Only 2 periods and a substituent. Now, how do we count it? I told you guys already. You have to look for the, what do they call it? Now in this step now, you have 2 bridge. But where do you start from? The lower them. And from here, I could easily count. I have 1, I have 2, I have 3, I have 4. Now, and first and foremost, how done this is the lower bridge. From here, connecting from here, I have 1, 2, okay, I have 4. That's 1, 2, 3, 4. While connecting from here, 1, 2, 3, 4, 5. I have 5 period. So therefore, I have to start from here. 1, 2, 3, 4, you have 5, you have 6, you have 7, you have 8, you have 9, and you have 10. So therefore, what is our naming? Easy. Spiro. Who is your guy? Nigeria will understand this. Spiro, and how do we give reference to it? Also the same way, instead of you giving from decreasing, you move from the increasing order. That's 4.5. Then our parent chain, you have decane. So Spiro 4.5 decane. And now when it comes to substituent, I told you guys you have to give orders to arrangements. And you have to start from the smallest, as we all know. So we have how many degree counting here? 1, 2, 3, 4. You still have 4. And we have 1, 2, 3, 4, 5. We have 5. Are you with me? So having 5, if we have to start our counting from here, 1, 2, 3, 4, 5. Still the same thing as counting from here. So now it depends. Let's count from 1, 2, 3, 4, 5. So this pointing out depends where I'm to count. Should I count like this or I should count like this? If I'm to count like this, I have 6, I have 7. I'll meet the subject at 7. If I'm to count like this, 6, 7, 8, 9. Nah. I can't meet the subject at 9. This is way too big. So I'm counting from here. I have 6, I have 7, 8, 9, and what? We have 10. So when you want to name this, the methyl group, you have 7 methyl. Are we there, guys? And you have the, who is your guy? Spiro. Then from the lower to the highest, 4.5. Then you have your decane. So please, guys, I hope I was able to nurture, feed these questions to make it grow bigger inside of you. So please, I guess I deserve a little bit. Just punch the subscribe to give me half. So please, guys, thank you. And my name is Crypto Quanta. Please hit the subscribe button.